I just had to let you know you're.
So let's get into the question one. The question one is explain the meaning of differentiation and what are the techniques of differentiation. So I would like to make this question split into two. So the first one is meaning of differentiation. After I explain, then I'm gonna go into techniques of differentiation. So let's get into the meaning first. So general meaning, differentiation is a branch of calculus that studies how a quantity changes with respect to another quantity. It is the process of finding the derivative of a function. Let's say if y equal fx, differentiation finds how fast y changes when x change. The derivative is written as dy over dx or f prime x. After explaining the meaning of differentiation, let's get into the second one, techniques of differentiation. There's a lot of techniques of differentiation, so let's get through it one by one. The first one is constant rule. The constant rule states that the derivative of a constant is always 0. Okay, let's get into the picture. D over dx, k equal to 0, where k is any constant number. So let's see example 2. D over dx negative 15 equal to 0, where negative 15 is a constant. So that means it will equal to 0. Now we get into the second one, is power rule of differentiation. The power rule is used to differentiate expressions involving powers of x. So let's see the picture, d over dx, x power n. So after differentiating it, the power n will times with x and the power itself will minus to 0. So steps of the power rule, multiply the expression by the power n. Second, reduce the power by 1. The third one is constant x function rule. The constant x function rule states if a function is multiplied by a constant, the constant remains unchanged while differentiating. You can see the formula itself in the picture where c is a constant, fx is a function of x. When differentiating, the constant can be taken outside the differentiation operator. You can see the example 3. So the fourth one is logarithmic function. A logarithmic function is a function that contains a logarithm. It is the inverse of an exponential function. A logarithmic rhythm answers the question, to what power must be the base be raised to obtain a number. So let's see the example, d over dx ln x equal to 1 over x. Any ln x will be equal to 1 over x. So let's say the second one is ln fx. If we differentiate it, it will be 1 over fx. Then you need to differentiate the fx itself. 5 is exponential function. An exponential function is a function in which the variable appears in the exponent. In exponential function, the base is constant. The exponent changes. This causes the function to grow or decrease very quickly. Real-life application, exponential functions are used in population growth, compound interest, radioactive decay, spread of disease, physics, and engineering. Number 6 is trigonometric function. Trigonometric functions are functions that relate the angles of a triangle to the length of its sides. They are widely used in geometry, physics, engineering, and calculus. So the 6 main trigonometric functions are, first one is sine, second cos, third tangent, fourth cosec, 5 secant, and 6 cotangent. So there's a lot of formula in trigonometric functions you need to remember. 7.1 is sum and difference rule of differentiation. The derivative of sum or difference of function is equal to the sum or difference of their derivative, where fx and gx are functions of x. Differentiate each term separately while keeping the same sign. Number 8 is product rule. The product rule is used when two functions are multiplied together to differentiate the product of two functions. The step is keep the first function unchanged and differentiate the second. The second step is add the second function unchanged multiplied by the derivative of the first. 9th is quotient rule. The quotient rule is used when one function is divided by another function, meaning to differentiate a quotient rule, multiply the denominator by derivative of the numerator. Subtract the numerator multiplied by the derivative of the denominator. Third is divide the result by the square of the denominator. Lastly, chain rule of differentiation. The chain rule is used to differentiate the composite function, a function inside another function. The chain rule says differentiate the outer function first, keep the inner function unchanged, then multiply by the derivative of the inner function. Steps of the chain rule. The first one, identify the outer function. Second, identify the inner function. Third, differentiate the outer function. And fourth one, multiply by the derivative of the inner function.
Assalamualaikum and hello everyone. My name is Muhammad Nazif Adli and today I will be presenting question 2D. The question is, find dy over dx for the following function and simplify. Given y equal to e to the power of negative 2x divided by 1 plus 3x squared. First of all, you need to know quotient rule. The formula for quotient rule is dy over dx equal to v u prime minus u v prime over v squared. Then you need to identify which one is u and which one is v. U is e to the power of negative 2x, and v is the denominator, 1 plus 3x squared. And then you have to differentiate u and v to become u prime and v prime. After you differentiate u prime will become negative 2e to the power of negative 2x, and v prime will become 6x. And then substitute into the formula, and it will become dy over dx equal to 1 plus 3x squared times negative 2e to the power of negative 2x minus e to the power of negative 2x times 6x divided by 1 plus 3x squared. And then you need to expand the expression. Make sure you expand carefully. For the 1 plus 3x squared times negative 2e to the power of negative 2x will become negative 2e to the power of negative 2x minus 6x squared times e to the power of negative 2x. And e to the power of 2x times 6x will become 6x e to the power of negative 2x. And then put inside the equation. It will become dy over dx equal to negative 2 to the power of negative 2x minus 6x squared times e to the power of negative 2x minus 6x e to the power of negative 2x over 1 plus 3x squared. And then factor the common term. It will become dy over dx equal to e to the power of negative 2x times negative 6x squared minus 6x minus 2 divided by 1 plus 3x squared. And then you need to rearrange the terms, and it will become dy over dx equal to negative 2e to the power of negative 2x times 3x squared plus 3x plus 1 divided by 1 plus 3x squared. And that is the final answer. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Jam Haikal bin Jaspa from JCS 142B. Today I want to present about my question 3D. The question is x square y equal to cos open bracket x plus y close bracket negative e power 3y. Find dy over dx of the following equation using implicit differentiate. So first of all, we have to identify the equation first. So we have to look the left side. So when we look the left side, we to know we have to use a power rule. What is a power rule? Power rule is a u prime v plus u v prime. So u is a x square, v is a y, u prime is 2x, and v prime is dy. Why dy? In this question, we have to differentiate only x. Why we don't have to differentiate it? So we replace y to dy over dx. So power for the left side, we know 2xy plus x square dy. Then we go to the second step. So the second step, we have to identify the equation. Then for the right side, we have to use trigonometric function which is cos fx equal negative sin fx times fx. So the equation is negative sin x plus y times x plus y. Then we have to expand it. When we expand, we got a negative 2 sin x plus y minus 2 sin x plus y dy. Okay. Then in the right side, we have two function we have to use. First trigonometric function, then exponential function. So after we done using a trigonometric function, we have to use a exponential function. So exponential function is a dy d over dx e fx equal e fx bracket d dx fx. Then we substitute our equation into the formula. So we got a negative 3y equal negative e 3y bracket 3 dy. So we got a negative 3e dy. After we done use all the function, then we have to combine step 1 until 3 in the question. So we have to replace it. So first of all, we write again 2xy plus x squared dy equal negative sin x plus y negative 2 sin x plus y dy minus 3e power 3y dy. Then after we wrote it, we have to arrange all the terms. So we have to bring dy function into the left side and the another in the right side. So we can write 2 sin x plus y dy plus x squared dy plus 3 e power 3y dy equal negative 2 sin x plus y plus 2xy. So for the last step, after we factorize, we got dy 2 sin x plus y plus x squared plus 3e power 3y equal negative 2 sin x plus y plus 2xy. Then after we factorize, we have to make a dy as a single. So what we have to do, we bring all in the left side to right side. So we have to divide it. When the left side go to right side, we have to divide. Then after we divide, we got a final answer. The final answer is negative sin x plus y plus xy over 2 sin x plus y plus x squared plus 3e power 3y. Then we got a answer. I think that's all from me. Thank you.
Hi everyone, my name is Putra Muhammad Alif bin Muhammad Arif, and today I will explain how to use linear approximation to estimate the value of square root 5 times 1.04 square minus 1 correct to 4 decimal places. First, we use the linear approximation formula. Fs equals to f at 0 plus f prime at 0 dx. We choose x equals to 1.04 and x0 equals to 1 because 1 is very close to 1.04 and it is easier to calculate. Next, we find dx equals to x minus x0. dx equals to 1.04 minus 1 equals to 0.04. 1.04 we change to x. We rewrite in index form. Fs equals to 5x squared minus 1 power of 1 over 2. Next, we differentiate the function using the chain rule. F prime x equals to 1 over 2 times 5x squared minus 1 power of negative 1 over 2 times 10x. After simplifying, we get 5 prime x equals to 5x over square root 5x squared minus 1. In this step, we bring down the power 1 over 2, subtract 1 from the exponent, and multiply by the derivative of the inside function, which is 10x. This method is called the chain rule. Finally, apply the linear approximation formula. Fs 5 times 1 square minus 1 plus 5 times 1 over square root 5 times 1 square minus 1 dx. dx we have 0.04, and final answer we get 2.000.